So this is the start of section 6.1, and I wanted to walk you through page 362 and page 363. As you look at all the objectives, I think that's always going to be a good thing for you to look through and to think on, even start some index cards or sticky notes or highlighters, but to start to wrap your brain around all the stuff that we're going to do in 6.1. It's a lot of items, but when you start to distinguish them in your brain, they'll make sense. We're going to talk about angles and degree measure. You may have had a geometry class and have done this before. You just need to see what it's going to look like in trig, if not the same thing. We're going to convert from a decimal to a thing called degree minutes seconds. We're going to find a thing called an arc length. I'm going to ask you to memorize that formula. We're going to convert from degrees to radians and radians to degrees. It's no big deal, but you got to know what to use and which way to use that ratio. Find the area of a sector and find linear speed. And so this starts by telling us that we have these things called angles. And I'm not going to read every piece of this. I'm going to hit some highlights like we were in class face to face. The cool thing is you can always stop this video, listen back to a part that didn't make sense, and you've got this to read in front of you also. So if the rotation of the counterclockwise direction, then we're going to call the angle positive. If the rotation is clockwise, we're going to call it negative. And so what's going to end up happening, and I'll try to jump ahead to what you're going to see, but yet stay where we are. And so when you have your quadrants, quadrant 1, 2, 3, and 4. It was just talking about clockwise and counterclockwise. We're going to talk about our angles, and we're going to do all sorts of things with our angles, and this is trigonometry, so it's triangles, and it was just talking about depending on which way an angle goes. And so if we have an angle, and I'm going to go ahead and draw it with, and we'll talk about what this is in just a minute, right there, we're going to call this 0 degrees. And this one up here is going to be 90 degrees, and 180 degrees, and 270. You're going to need to memorize those. And when we get back around here, it's going to be 360. And you will memorize those because we'll use them so much. But if we wanted to draw, let's say a 90-degree angle, I'll start with that one because what I've got in red is a 90-degree angle. But I like to go ahead and see it on the quadrants because that's where we're going with our information. But they start to give us some really good details, like an initial side and a terminal side. And so when you look here, this on the x-axis is my initial. Where I stop to make a 90 is my terminal. It's the end. And so you see some information here in the arrows. You see a little arrow calling it alpha, and then the arrow going this way and calling it beta. And then, oh, let's go all the way around and then come on back up. That one's going to be another angle that we'll talk about. And we'll talk about that we can spin around a bunch one way or spin around a bunch the other way. This is just an introduction to let us see what is happening. And I've got a little side note over here about a reference angle and a coterminal angle. And then I just jotted down, it's an angle in standard position. Here's our standard position. And it's the acute angle that is formed by the terminal side of the horizontal. Wow, that's a whole bunch of stuff. But we are going to talk about reference angles that end at the same place. And when they end at the same place, they're coterminal, and that just lets us be lazy. Then that way, if we know what we'll talk later about the angle, I'm not going to get into that, but the things that we'll talk about it, we're going to get to know that if they have the same terminal side and the same initial side, even though they may go around a bunch, we're still going to call them the same angle. Another thing it's telling us is that we are going to use some Greek letters, like this alpha, a beta, a gamma, and a theta. And so we will use alpha a bunch, and you just kind of write it like that, like a little fish. We'll use beta, which looks like a bee with a tail. We don't use gamma as much, but we do use theta, which is like a circle with a little thing in it. And we often use those to denote our angles. Down here we've already mentioned standard position. And when you're looking here at standard position, it's talking about the initial side is on this x-axis. And so that's the way I've drawn this one. Is it, is you see that I've started with my initial and my terminal, and they're calling that standard position. We're going to use that over and over and over. That's why I like to even just start with it when they're just talking about something out in the middle of the air. So I'm at the top of page 363. And then it talks about standard position, and then that theta can lie in a quadrant. But then there are some other angles that we can, with case of theta, that is called quadrantal. And for example, quadrantal, and if you look at 4C, it's landing down here. Well, the one I drew is a quadrantal because it did not land in a quadrant, it landed on one of the axes. And so if you're looking at this one that they've drawn here, and I keep trying to adjust the focus, and it's kind of working. But if you look at this angle here, it goes through 90 degrees, through another 90 degrees, through another 90 degrees, and we're going to call that one 270 degrees. You need to memorize some standard numbers, and it's going to make you faster in your calculations. And so I'm going this way on my angles, and I'm going this way to get the 90. If I went all the way to here, it'd be 180 to 270, and all the way back around would be 360. Angles are measured by determining the amount of rotation needed for the initial side to coincide with the terminal side. And the two commonly used measures, we call them, are degrees and radians. So this moves us into, hey, there's this thing called a degree, which you're probably very familiar with it, but we need to talk a little bit more that we will call the 90 degrees specifically a right angle. We will call the one that's 180 degrees specifically a straight angle. So you really need to start vocabulary like on an index card, like put right angle on an index card, put straight angle on an index card, and define it or draw a picture on the other side. But I've got some more stuff drawn in here that I really want you to note because it happens over and over and over during our time together. So this little piece I drew in here is a quadrantal, and that's what I was already messing around with here. When we land on one of the axes, it's going to be called quadrantal. But then you notice I've got some more information going on. I'm calling these 60s, and over here I'm calling these 30s, and I'm calling these 45s. And so I would pause or take a screenshot or play around with these, because the 30, 60, 45 we're going to use over and over and over. And so the familiarity you have with them is going to increase your speed and your understanding, and you're not going to get bogged down with where is a 120 degree angle or where is a 225 degree angle. And so I'll go through, probably the hardest one to see over here is the 30, so I'll do it. And when I'm looking here at my XY coordinate plane, which you cannot see, when I'm looking at my XY coordinate plane, I want to play around with all the 30s. And all the 30s are going to come off of the X, come off of the X. Our 30s are not going to come off of the Y. They're all going to come off of the X. And so right here is probably our nicest one. When I draw this one, it's about-ish, 30-ish degrees. And so then you're going to have to think quadrantal, and you're going to have to think, well, what if my angle goes all the way around here, but yet it comes off 30 degrees? You got to remember 180 gets us all the way around, and so 180 come off of it the 30 degrees. This angle from our initial to our terminal side, this angle is going to be 150 degrees. And you can kind of see what I've already got written over here, that there's a 30, there's a 150. Well, what would this one be down here that goes past the 180? 30 degrees. Because all of these are going to have items that are similar because they're all based off of it's not a coterminal, but it's going to be our reference angle. And 30 degrees, knowing that it's a 30, is going to save you a lot of time, energy, and effort. So if this is a 30 degree, but yet it has passed the 180, then we'll end up adding it, and we'll call it all the way around to here. We'll call that one a 210 degree angle. And so here, we got one more to go. But we could keep going around and around and around, clockwise and counterclockwise. We're just going to stop right here, that if I've got 30 degrees to get up to 360, I'm not all the way to 360. I got to back off 30. So that one would be called a 330 degree angle. So what I would encourage you to do is to stop right now and do this for the 45s. Practice it. Practice calculating them. I would also do this for the 60s, because you're going to hear me say 30, 45, 60, 30, 45, 60. Don't forget your quadrantals all semester long. So then it asks us on example 1, it asks us to draw these given angles. So I'll play around with them, because we're not looking for perfect. We're looking for about-ish, because every time you'll hear me say, draw the angle, draw the picture. So looking at this, if from here is 0 to up here is 90, we have to know that half of that is 45. So if I just split the difference, and I went more towards 60 on that one, but split the difference and label it, then it becomes a 45 degree angle. So we have now drawn a 45. Part B says, let's draw a negative 90. The negatives are going to go clockwise. And so if I'm going to draw a negative 90, here's always where I'm starting at my initial side. But negative 90 goes that way. So I'm not even on my quadrant. Good grief. So here's my 90 degree, actually a negative 90 degrees. But wait, there's more. So here's this 225, and you're like, 225? I don't know what that is. But if you played around with it like I asked you to stop the video and look at, you're going to remember that, oh, wait, 225, oh yeah, 225, it's going to be over here between, whoops, you can barely see that. It's going to be over here between my 180 and my 270 that I've got memorized. Oh, and it's got that 5. I bet it's going to be related to a 45. Let me just even try. If I added 45 to that, looky, 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 I'm getting that my 225 starts here, and it goes all the way around to the third quadrant. Bring that one back up for some good old math, because we're going to need to talk about our quadrants. So then this very last one says, oh wait, by the way, let's go crazy here. Let's go crazy and look at a 405 degrees. And your brain's got to immediately think, wait, I'm only able to go 0 to 360. So one loop around the sun here gets us 0 to 360. So you got to figure out what makes sense to you, what you like doing. But your brain's got to see that if I go ahead and take out this full loop, if I take out a 360, and I can do my borrows and all my other good stuff like that, well, looky there. It goes on up to here, and so my 405 degree angle is really just a 45 degree angle in the first quadrant. Ah, then that's going to help me to figure out stuff like, well, what we're going to get to in this class. So really take a moment to think on this, to pause. Oops, the rest I'm going to send you to the videos in the book, and then I'll ask you to do some examples. I'll be adding some in between, but for right now, this ends the introduction on section 6.1.